Hello. Testing. Okay, we do have audio, thank goodness. Um, I am recording a lesson 4.4 right now. I do not have my iPad today, so we are doing things a little different with this video. I'm gonna do my best to write with my mouse, okay? And we're gonna make this work. This video is gonna be short, sweet, to the point though, since I'm not able to write as much as I would like to. Um, so we're gonna be solving equations that look like these guys, right? These are equations that have roots in them. In the end, we're just trying to solve for x, right? In the end, we're just trying to solve for x. You just got to get x on its own. So if we were solving these by hand, right, especially a here, we need to somehow get rid of the radical. And what do we do to get rid of a radical? We square it, right? Those are the types of things that we're going to be doing. But we're going to first start out by solving by graphing. And we have solved by graphing before. If you recall, basically we would graph the left side. I'm going to write GL. We would graph the left side, and then we would graph the right side, and then wherever they intersect is our solution. Do you remember doing that? We've done this before. And that's exactly what we're going to do today for today's quick lesson. I'm going to talk about extraneous solutions in class, so I'm going to leave this blank, and this can be something that we fill in together in class. And I'm just going to focus specifically on solving by graphing today. So I'm going to do exactly what I just said. I'm going to plug in the left side, and I'm going to plug in the right side. All right, so let's go ahead and do that in Desmos here. I'm not going to try to do it by hand. I'm just going to use Desmos. I might as well, right? So if you see here, square root of x plus 5 plus 4. So let's type that in. So what does that mean is going to happen? Plus 5 means left 5, and then plus 4 means up 4. So you can see there that it starts at negative 5, 4. It went left 5, up 4. And then I'm going to plug in the right side, which is simply 7. So if you just type 7, it doesn't do anything. So you have to specifically type y equals 7. You can type y equals for this guy too. It doesn't really make a difference. So wherever they intersect is our solution. And you can see here that they intersected once at 4, 7. So the solution for x is simply 4. So if I'm not even going to bother, right? I'm going to do the roughest sketch of all time. It looks something like this and then like this. The point is they intersect at x equals 4. Okay? That is the solution for x. I guess there's a space right there for me, isn't there? The answer is 4. It only touches the one time, right? You see that? It's only touching once. Sometimes, though, it might touch twice. Okay? Sometimes, though, it might touch twice. And we'll see that happen here briefly. So, if we look at this graph, it really is that simple, people, right? Let's not overcomplicate it, all right? Wherever they intersect, boom, it intersects at 4. Let's move on to the next one. Plug in the left side of the graph. So this is a cube root function, right? So it's not just a square root, it's a cube root. And if you recall, cube root functions look like, so I gotta click on the keyboard down here in the bottom left, and then click on functions, miscellaneous, and then there's the cube root. So I make that a 3. And remember, cube root functions look like this, right? They go on forever. There's not a clear starting point. Let's go ahead and edit this appropriately. It's going to flip because of the negative, and it's going to move down 5 because of the minus 5. Some of you might look at that and think it's going to move right 5, but the thing is it would move right 5 if that was under the radical, but it's not. It's on the outside of the radical, so it's moving down. And here I'll show you, right? Minus 5 under the radical moved it right 5, but it's not under the radical, it's outside of the radical. So boom, it moved it down 5, and then don't forget about the negative. So there's our graph. And then we need to punch in the right side, which is simply negative 3. Y equals negative 3. It looks like here it only intersected once as well, but there's without a doubt a chance that it could intersect twice. Let me just spice it up and do this, right? And then how about trying to make it intersect twice? Ooh, you see that? It actually touches 3 times. Isn't that crazy? 1, 2, 3. So there would be 3 solutions. Okay, and that's perfectly okay, right? There can be more than one solution. Right now, the 2 that we've seen, there's only been 1. And you can see here that it's intersecting at the point -8, -3. So the x value is -8. So boom, the solution is -8. So our graph looks something like what? This. And then the -3 came in. Again, you don't really need to bother with this too much, right? We're all going to be plugging it into Desmos anyway. The point is that the intersection, that's just bad. That's just really bad. Let me undo that. -8 is 6, 7, 8 clear out there. So, boom. Something like that, right? So there's the intersection. X equals -8. I think this one's going to intersect twice, if I remember correctly. So again, keep it simple, people. Don't get stressed. You graph the left side, you graph the right side. Where do they intersect? That's your solution. That's all we got to do. Okay? Because that's what equals means, right? Because this is a graph on the left and a graph on the right, right? Those are 2 separate functions, and we want to know when are they equal. Well, to be equal in a visual sense means that they're intersecting, right? That's something that they share. That's a spot on their graph where they are identical, or in other words, equal, right? For a graph to equal a graph, visually speaking, that's an intersection. That's why we're looking for the intersection. So one more time, this one's a square root function, and make sure to be alert for that when you are graphing these yourself, right? Don't forget to change back to square root if necessary. Okay, so the square root of x plus 2 equals, well, not equals, sorry, graph the left side and then graph the right side, which is x plus 2 again, but not under the radical. Ah, finally, there we go. There is our 2 solutions, right? It intersected not once, but twice. So those 2 x values are our solution at -2 and at -1. Kind of cool, right? So if I were to graph this back over here, if I were to try to be somewhat accurate, something like that, right? And then x plus 2 is something like that. It intersects not once, but twice. Once at -2 and -1. Don't overcomplicate things, right? We have done this before. We did this with parabolas, I believe, right? Where we were graphing the left side, graphing the right side. Where do they intersect? This was some of our best quizzes because it really is that easy, right? I mean, like, do not overcomplicate this. Graph the left side, graph the right side, 2 separate functions. You can see here, 2 separate functions, and then observe where do they intersect. Sometimes it'll come out nice. Sometimes maybe it'll come out as a decimal. You got to live with it, right? It can be as messy or as pretty as need be. Desmos is your friend here. Voila. And as I said, I don't have my my iPad on me today, and I really don't want to try to write with a mouse. I just think it's going to come out really ugly. So we'll just spend some time on this in class. that's the 10-minute mark right there on my end. I can see the timer going up. I think that's a beautiful, short, sweet, to the point video, and you could totally get started on the classwork if you wanted to. So yeah, let's just leave it at that. Thank you for watching this brief overview of solving radical equations. I'll see you in class.